Inverse function. Let's imagine we have a machine function f and the inverse function of f. So the denotation is f of inverse function f in exponent minus 1. Usually, but sometimes we can take just one function. For example, the function g is the inverse function of function f, etc. We can write differently, but usually in a standard denotation we can write function f, for example. The inverse function of a function f, we denote with the f in exponent minus 1. And this is the inverse function. This is function. Imagine that we are inputting in the function apples, and the output is a lemon. But if we input the lemons in the inverse function, the output is going to get apples like it was the input in the function. So function f of x and its inverse function f minus 1 of x. So let's see, for example, in the order pair, how we can interpret the function and its inverse. For example, we have points 2 and 9, order pairs 4, 5, and 11, 6. So the domain we already know is the first coordinate of the point is 2, and here is 4, here is 11, and the range is 9, 5, and 6. But in the inverse function, they're going to switch the domain with the range. So whatever was here a domain, here is going to be the range. Whatever was the range here in the function, in the inverse function is going to be the domain. And as we see here, everything is switched. For example, in the function we have order pair 2 and 9. 2 is a domain, 9 is a range. 4 is domain and 5 is range. And here is 11 and 6. 11 is domain and 6 range. Here they are going to switch. The 9, for example, is going to be domain and 2 is going to be the range. And here 5 is going to be domain and 4 is going to be range. And in the third point, 6 is domain and 11 is a range. So let's see now inverse function, how we can apply the horizontal test. In order for us to know the function has an inverse, it has to pass the function horizontal test. Not just the vertical test, because the vertical test, do not mess up with the vertical test, because the vertical line test proves or verifies just a equation is a function or not. But in this case here, when we do in the horizontal line test, we're proving does the function has inverse. So now let's see here, does every function have an inverse? No, a function must be one-to-one or pass the horizontal line test in order to have an inverse. For example, here, if we are drawing a horizontal line, the horizontal line is going to hit the graph of the function just in one point. And same thing with those two lines. So it's similar with the vertical line. If the horizontal line hits or intercepts just in one point with the graph of the function, it means it passes the horizontal line test. So this one is it has inverse. But for the second one, quadratic function, for example, if we are drawing here a horizontal line, it's going to hit in two places, here and here. So this quadratic function, they don't have inverse. They may have an inverse just in a restricted domain, but not in a whole domain. Let's go here and let's see two functions. Cubic function, when it is the form x cubic, this one has inverse function, and its inverse function is a cubic root of x. So the blue function here is inverse, and with the red we write the function x cubic function. So if we are interpreting geometrically and we draw the line, which line is y is equal with x, so the function f of x is symmetric with respect to y equal with x is symmetric. So if we look in, for example, its inverse and function f of x, those are symmetric with respect to the y. If, for example, I'm taking any point here, and if I'm drawing a line perpendicular to the line equal y equal with the x, and I'm drawing here, let me draw with a different color here, maybe we can see a little bit differently. And now the same line I'm continuing, and this line, for example, is perpendicular. This segment is perpendicular to the line y is equal with the x. Now the distance from here from the graph of the inverse function, from the point here to the line y equal with the x, is equal. This side here is equal with this segment from the graph of the function, from the point of the graph of the function to the line y is equal with x. So these two segments are equal. Not just two segments, any 2 points. If we are drawing the line from the segment to the a segment perpendicular to the line y is equal with the x is going to be in both sides equal, because this is a symmetric with respect to y. But here, as I said before, if we are taking quadratic function, they don't have inverse function. But if we are restricting the domain, if we are restricting from 0, the domain, for example, if we are restricting from 0 to infinity, so, and in the first quadrant, just in this quadrant here, in first quadrant, it has inverse function. Just in this quadrant, it has inverse function because of this part of the function is 1 to 1. So if we are drawing the line, if we look geometrically how it's interpreted, the function f of x is a symmetric with respect to y equal with the x with its inverse function.